How does electricity affect your world? Look around you.
It's everywhere. It runs your home, schools, businesses, and industries.
It's like magic. Unseen power available at the flick of a switch. Of course it isn't magic. It's people using technology to improve lives. But where does it come from? How is it created? To find out, let's take a look and see what's behind the switch.
Spurlock Station is located on the Ohio River near Maysville, 60 miles from Cincinnati. It is the largest generating plant owned by East Kentucky Power Cooperative, or EKPC for short. It is also one of the largest in the state, capable of producing more than 1,300 megawatts, which is 42% of EKPC's generating capacity. The plant is named in honor of H.L. Spurlock, who was the co-op's first general manager. He dramatically improved life in the Commonwealth by leading the effort to bring power to Kentucky's countryside in 1954. There are 4 coal-fired units at Spurlock Station. The first went into operation in 1977, and we added the second in 1981. The third unit, the E.A. Gilbert Generating Unit, began operating in spring 2005. It is named after the late Edgar Armstrong Ned Gilbert, a longtime chairman of our co-op and a hero from World War II, who also was a leader in bringing electric power to people across much of Kentucky. Our fourth unit, which is identical to unit number 3, was added in 2009. EKPC is a not-for-profit co-op based in Winchester. EKPC operates Spurlock Station 24 hours a day, 7 days a week, by a dedicated team of more than 200 employees. We generate and transmit power to 16 cooperatives, serving the eastern 2/3 of Kentucky. These 16 co-ops own our cooperative and distribute the power to homes, farms, and businesses. Like us, the owner-member cooperatives exist for people, not for profit, to make life better in Kentucky. They provide power to more than 1 million Kentuckians in 87 counties. Together with our owner members, we're known as Kentucky's Touchstone Energy Cooperatives. Spurlock Station has prepared for a bright future by installing scrubbers and cutting-edge environmental controls to operate 4 of the cleanest coal-fired generating units in the nation. This video will explain the inner workings of the steam turbines and generators that our owner members use to produce power for more than 1 million people across the state. To understand the inner workings, we'll look at the power production process from beginning to end. Coal is delivered to the plant by barges on the Ohio River and also by trains, and it is carried into the plant by a system of conveyor belts. It may come as a surprise, but Spurlock draws a good portion of its water from deep wells, in addition to the adjacent Ohio River. Now here's how the fuel and the water are used to generate power. Coal enters into the plant on conveyor belts and then into a boiler, where it is burned to create heat. The water is pumped into the plant and converted into steam by the heat of the coal combustion process. The steam flows through a maze of pipes in the furnace to the turbines. To understand how this works, let's first look at the turbine blades. You can see the blade in the turbine has an airfoil shape. The steam lifts and rotates the turbine. The turbines in each unit are connected to a single rotating shaft that is connected to a generator. That generator turns in a magnetic field and produces electricity. To ensure that the generation and the transmission of the power produced is safe, efficient, and complies with all environmental standards, operators are on duty in the control room 24 hours a day, 365 days a year. They monitor steam pressure, steam flow, water temperature, generator output, emissions, and a host of other variables. They also control the transmission of the generated power. But before we follow that path of the power, let's back up a couple of steps.
We've talked about how electricity is generated through heat and water, and that's true for each of the 4 units here. However, there's a major difference in the way coal is burned in Units 1 and 2 and the way it's burned in Units 3 and 4. First, let's see how it's burned in Units 1 and 2 and the entire process in closer detail.
Units 1 and 2 use a more traditional technology. In Units 1 and 2, coal, ground to the texture of baby powder, is blown into the boiler where it literally explodes, burning at a rate of 2,600 degrees Fahrenheit. After the initial burn, the resulting ash, depending on its weight, exits the top of the furnace or falls to the bottom. If it exits via the exhaust stream, it's fly ash. If it falls to the bottom of the furnace, it's bottom ash. The fly ash is caught in electrostatic precipitators. The flue gas then passes through a unit called a selective catalytic reduction module, or SCR, to remove nitrogen oxides. It also passes through a scrubber, which removes the sulfur dioxide. The gas that exits the plant meets all EPA standards to protect the environment. Please keep in mind, when you see the white plume above the stacks outside, this is water vapor from the scrubber process.
Units 3 and 4 use a completely different technology to burn coal. They are called circulating fluidized bed units, or CFB units for short.
In a CFB, the boiler has a bed of material in the bottom and a constant high pressure that lifts this material much in the same way as an air hockey table operates. Coal not ground as fine as in the conventional boiler is mixed with limestone and fed into the boiler. As the coal burns, it rises on the air and then falls back down the sides of the boiler. It makes this circuit about 3 times before it's light enough to go into a unit called a cyclone. The coal particles are still too heavy to exit the cyclone, so they are fed back into the boiler's combustion chamber. They make this circuit, cyclone to combustion chamber, about 2 or 3 times before all combustible material is consumed, and they are light enough to exit the cyclone. The particles, now ash, are in the flue gas, and it's this ash that gets trapped in the bag house, which works like a huge vacuum cleaner with bags to remove particulates. The flue gas, now stripped of ash particles, exits the stack, colorless, odorless, and completely in compliance with EPA standards. Notice that there is no scrubber in the CFB process. Why? Because with CFB technology, a scrubber isn't necessary. Remember how the coal is mixed with the limestone in the boiler? That ground limestone reacts with the gas in the combustion chamber and captures up to 98% of the sulfur dioxide. And since the unit operates at about 1,600 degrees, much lower temperatures than the pulverized coal units, the amount of nitrogen oxide created is negligible. Now let's go back to the control room. We've created the electricity. As electric power leaves the plant, it must be sent across the system, often over long distances, to reach homes and businesses. The power passes through huge transformers that increase the voltage as high as 345,000 volts before sending it on to the switchyard. From the switchyard, the power will be dispatched along various transmission lines that carry it to substations across the service territory. Transformers in these substations are used to reduce the voltage before sending it along the lines to the local cooperative. These lines carry the power to homes, farms, small businesses, or manufacturing plants served by one of our 16 owner-member cooperatives. At the very end of the journey from power plant to your home, the power passes through a transformer atop a pole. This reduces it to the standard voltage required by most electric appliances. Throughout this entire process, we go to great lengths to make sure our environment is protected. Not only have we invested heavily in the latest equipment, each year we nurture endangered peregrine falcons in a falcon box installed over 600 feet high on one of the stacks. Dozens of chicks have hatched since this program began in 2006. In addition to protecting the environment, our employees work 24/7, doing everything possible to ensure that affordable, reliable power reaches your homes and businesses every day. That is what is behind the switch, people using technology to make life better. It's the reason our co-ops began, and it's why we exist today, to serve our owner members and make lives better. It's why our cooperative is much more than power plants, lines, and substations. Our cooperative is about families. It's about communities and people. They connect us to our values and our mission to safely deliver reliable and affordable power.
That's the power of human connections. And that's what's behind the switch at Spurlock Station.